Jumping on now to distributions of sample means, which is a little bit different to what we did before. So I just included up at the top here that remember when we're looking at SN, that was a sampling distribution, which was the sum of the observations. So that's when we're, I suppose, adding together all the different observations. What we're going to talk about here is just a little bit different, which is the distribution of the sample means. So probably the easiest way I find to sort of discuss or try and understand what a distribution of sample means is really if you think about, say you were going to buy cans of Coke in a carton. So say you're going to Woolies and you're buying a carton of cans of Coke. Within that carton there was several 6-packs. And imagine you were finding the mean of each of those 6-packs, or how, in terms of how many mils were in those Coke cans. So say you had you bought a carton that had 36 cans in there, so that's 6 packs of 6. You could then find the mean of each of those 6 packs, and then obviously see what that distribution is of those means, and go from there. So hopefully as we do a few more questions and we get more used to this, it will become more familiar. But what I want to talk about now is, so here, if you look in this top box here, it says for n independent observations of a random variable x, the mean of the observations is the random variable xn, where we add them all together and divide by how many they are. So that's really just finding the mean, as you would know. If the random variable x has a mean mu, so say we know that cans of Coke are supposed to have a mean, I suppose, mean amount of Coke in the cans, which is what's in a can these days, 320 millilitres, something like that. So let's just say they have a mean of 320 millilitres with a standard deviation of 5 millilitres. Then the distribution of the sample means xn has a mean mu. So what we're saying is if you went and sampled a whole heap of different Coke cans and found their means, and then I suppose found the mean of those, you would find that the mean basically comes out to being the same as the population mean, and the standard deviation will be sigma on square root n. If you want to find out more about that, I can give you a different video that I have created if you want to know more. Just send me an email and I can send you through the link of that, that goes through it in a little bit more detail. And then I suppose the last thing I just want to talk about on this slide is as the number of observations in each sample n increases, the standard deviation of xn decreases. Hence, you've got the sigma over square root n. So if you can imagine you were looking at two Coke cans, you might have a distribution like this, but if you were sampling 50 Coke cans, it's obviously going to get narrower. And again, if you want that other video to look at that a little bit more, you can. So let's look at an example. So the life expectancy X of a certain brand of AAA batteries is known to have a mean of 27 hours and a standard deviation of 3.25 hours. The batteries are sold in packets of 6. Let the random variable X bar 6 be the mean life expectancy of the batteries in the packet. Part A says the batteries in a packet were tested and the number of hours they lasted were this. What is the corresponding observed value of the random variable X bar 6? So all question A is really asking for is you're going to find that X bar 6, you're going to add these values together and divide by how many there are. So obviously I can fit all of them in, but you know how to do that. And basically what that's done is found the mean of those 6 batteries within that pack. Now I suppose really what the distribution of sample means is about is if you went and purchased another 30 packs and you found the mean of each of those packs, so you might have found one that was 26.8, you might have found another one that was 27.2, 23.8, that's really low, probably wouldn't be 23.8, it might be 26.3, so on and so forth, and then you found all those means. If you then were to go and find the mean of those, or the average of those, you'd end up finding that the mean, when you found that again, would actually come out to be very similar to, I suppose, the population mean, which we've given in the question, which was the 27 hours. And that's why on that slide before, I said the mean will just end up being the same, and the standard deviation will end up being the standard deviation divided by square root n. That's where that comes from. But again, as I said, if you want to see an example on how to get that, I don't honestly believe the new textbook does that very well, but I do have a video from previously and I can send that to you, just ask me for that. But in part B, B is quite simple. All it's going to really ask for is the mean. So you can say mean of x bar 6 is going to be equal to 27 because it's the same as mu, and the standard deviation of x bar 6 is going to be equal to standard deviation, which is 3.25 divided by square root 6, which comes out to be approximately 1.33 hours. So hopefully that makes sense. But yeah, that's really where we're at with those questions. And the questions that align to the distribution of sample means are in exercise 9B on page 261. So you'll be given time to do these questions